And the labs we're going to do is, we're going to do I'll let you terminate a house plug and splice the wire too.
And that you saw that we were taking the European contract that worked on our voltage, that made it, put it on weird plug.
I didn't bring another one over here. This is a cable that we use in residential wiring and also commercial wiring, wire standard outlets. This is it's 14-2 with the ground. That's what they refer to it. It's also called Romax because it's been around a lot. So it says right here, if you can see it, it says 14/2 W/G. So that's 14-2 with the ground.
So 14 gauge.
14-2 conductor with the ground.
So theoretically, 3.
No, because the ground is not a conductor. The ground is in there for safety.
Okay.
So, in fact, NEC, the trade, they call the conductors, they call them hot, they call them neutral, and then they call it ground. And then, of course, what you do is we'll split it down the ground because the ground is uninsulated. So what you want to do is when you take your knife, you want to split it down to the center. And we say it's uninsulated, but in fact, it is insulated, but it's insulated with paper. So the ground has a paper insulator, which is this guy right here. You can see it's actually. Now, National Electrical Code calls the black wire, they call it, and we only have 4 colors available to us in residential wiring. We have 3-2, which is black, it's white, black, and red. And then we have 2 wire with a ground, which would be black and white. So the black and white is used on 120 volt, and it's also used on 240, but 240 we had a red one. So those are the only 3 colors that's available in residential wiring. Commercial wiring, you have all types of colors you can set up. But in residential, you only have 3 colors. Well, that's not true. You have 4. We have black, we have white, we have red, and then we have green. And the green might be green, and that would be another wire we use for ground. This is called, NEC calls this the ungrounded current carrying conductor. They call this the grounded current carrying conductor, and then this right here would be ground. So if you ever get in your paddle box, you'll notice that your neutral and this wire right here are connected together. They're on the same bus bar. We call that a bus bar.
Whenever we're wiring transformers, we always put the black wire on one pole on the secondary of the transformer, and then you put the ground and white on the opposite side. So we ground the transformer.
Well, technically, you shouldn't ground the transformer. You might ground the transformer's core, but not the actual,
not the primary.
Not the primary.
Yeah, we never ground the primary.
So, what we do is this conductor right here is not intended to carry current. What it's intended to do is only carry current when you have some type of fault.
Yeah, sort of problem.
Right, some type of problem. So, and then what a ground fault does, the ground fault measures the magnetic field on these 2 conductors right here. And whatever current goes out should be the same current on the other side. And if they don't match, then I think it's really, really low, like 100 millivolts worth of difference, 100 milliamps of difference. It might be 10. It trips your ground fault. So if the current in this conductor is not the same as the current in that conductor, then it's got to be going somewhere else, right? And that's what to a ground somewhere. That's why it's called a ground fault. A lot of people is under the impression that a ground fault keeps you from getting electrocuted. If you get across these two wires right here, you are a light bulb. Understand? But if you get between this one and this one, you're a ground fault. So the only time it would keep you from getting electrocuted if you get between the ungrounded current carrying conductor and ground. That's what ground fault tree. So what we do is we strip this, and then we'll come up and then we'll lay it over and then cut it off. And then also cut the paper off. And then we end up with so much exposed wire. Now NEC tells you exactly how long this is supposed to be. In fact, when you put it in a box, you're supposed to be able to pull out your receptacle at least 6 inches from the box. There's some electrical, all the rectangle, the box, any box that's got a device on it, you're supposed to be able to put 6 inches. And what they do is that leaves you at least 2 or 3 repairs that you can do, because once you get that, all this stuff mounted and stapled inside your wall, if you don't leave enough room for repair, then the only option you got is to splice onto it. They don't call it splicing inside the box, they call it a pigtail.
Yeah.
So when we look at a receptacle, so this is a 15 amp wall outlet. I think it showed y'all the 20 amp over there the other day, right?
Yeah, got the little thing.
So this is a NEMA 515. So the 5 is just the receptacle, and I'll show y'all. I needed to show y'all that too. The NEMA plugs. So NEMA usually standardizes mechanics, electrical mechanics, like different frames for a motor, different. So if you have a certain frame type, then if you got that same frame type from another manufacturer, it would mount the same.
Yeah, it should.
And it defines all the, basically it defines the mechanical. So this is a NEMA 5, 20. This is a NEMA 515, because the NEMA 520 would have the extra slot cut in the edge of the neutral side, right? And this is the connection. And basically, the way the thing works is, of course, I didn't bring a screwdriver, that if you ever look at a panel box, you only have one hot wire going into the circuit breaker. If it's a single phase circuit breaker, but it's not a single. If it's a high voltage breaker, you'll have 2 individual wires, but they won't be on top of each other. They'll have their own connection. Understand what I'm saying? So in our panel box, what we do is we have a circuit breaker, and it's got snaps on it. They do different ways. It has snaps on it. You snap it into the panel box, and then what you do is on this side you got a little slant coming in, and you have set screw. And you put one wire into that, and that would be either black or red, depending on that. You don't put multiple wires in there. All your paralleling is done out in the walls with your plugs and your lights. Does that make sense?
Yeah.
Well, if you got a 2-phase, if you got a 240, then you'll have 2 wires. And each one of them will have its own set screw. But you don't put multiple wires in a breaker. All your paralleling is done out away from the breaker, away from the panel. And then you have a big bus bar down here. It's got a bunch of screws for your grounds and your neutral. And then they'll come out here. So you'll see your grounds and your neutrals connected together, but your ground is not supposed to. Your ground only carries current if you got an emergency, and your neutral is a current carrying conductor.
Yeah.
The way we jump these plugs, and so normally when they draw it, they'll come up here and draw these plugs like this, but they're not actually done. What you do when you look at the thing is brass. This is for your hot. and then this is for your neutral.
So you would consider that to be your white side,
Now this will be your white side,
and then grass would be your black.
this will be your black side, and of course the green is the ground.
Yeah.
And this is what ground, this was established this, and then ground the whole receptacle. And if you got a metal box, it also grounds your metal box. In residential, we use plastic boxes, but in commercial, they use metal boxes. And the metal boxes are supposed to be grounded too. And then, but the parallel is done here. So what I would do is I come in from the bottom, the pins, and then we would connect our first wire in here, and the next wire would go out here.
Yeah.
Well, the problem with that is that if the plug ever goes bad, then even though you got insulated plugs and everything else, you would have to kill everything to work on that plug. So you kill everything downstream. So this is the way the parallel is done in actuality. Is I'll come over here and I'll bring my black in, and then my other black would come out down here. And then I would come over here and bring my white in, and then my other white would come out down here. So that actual paralleling of your receptacle is done this way here. Now this one doesn't have the push-ins back in the back. I'll go and look and see if we got one of those. We do have a method set up for 14 gauge wire where you can strip it and push it in there, but I don't ever use that because over time they get loose. So every plug I've got in my house that they use that method, it's real fast because you don't have to do any bending. All you got to do is just strip them off and stick them in there.
Yeah, you don't have to.
No, you just stick them right in the.
Yeah, then you're good. But
Well, yeah, but like I said,
so
every one that I've had, every receptacle that they use that in my house, I've had to.
Yeah.
So I wouldn't recommend that you would do that, and most electricians will tell you not to use that.
Yeah, we had to replace the whole set of thermal blocks on the machine that kept faulting out. And the customer knew why, and we figured that mechanical. They've got those push-ins, but it's like a mechanical screen thing where you press the screwdriver one end and open the hole.
Oh yeah, I've seen those too. Those
things are trash. Screw and terminal.
that was paused the whole time.
Oh, we were paused the whole time?
Yeah, I'm going to redo that. I think I had it paused when I did the receptacle too. I don't, let's redo the wire now. So what we're going to do is we're going to use the same piece of wire. We're going to use two pieces of the Romex wire. And then what you're going to do is you're going to splice them together. And then you're going to also come in and you're going to terminate them with a wire nut. Splice them with a wire nut. And then you'll terminate it on a regular wall outlet. Always strip away from you. Make sure you strip at an angle. So we're going to strip off about a half inch. About a half inch. By the way, I had my brother-in-law pulled out a light, not a light switch. He pulled out. What did he pull out? A light. And he thought he had to keep the electricity flowing. So he twisted the black and white wire together.
Wait, what? He needed to keep the electricity flowing.
Yeah, he thought he didn't know everything was hooked in parallel. So he pulled out a light fixture he didn't need anymore. There was another light on there, so he thought he needed, so the other light would work. He thought he needed to twist his black and white wires together coming out of his light fixture. And of course, as soon as he turned it on, break the trip. So we'll redo this. now that I'm recording. So we just bring the wires up, we put them together, we match them up, we grab them with our lineman pliers, and then we twist them in a clockwise direction. Okay, and then once we got it twisted together, we take our wire nut, screw it down. Hey, Jack. That's okay. I don't think I recorded it. That's okay.
I'll tell you this, that big board that was on for the siren, I checked that board all. I don't know if it's because of the cool weather outside or what, but I couldn't solve what's the
The next thing we're going to work on terminating is, I think I showed y'all the coax cable and the stripper, right? Is we're going to terminate some network cable. One step above it. I forgot what it was rated. I think it's 100 megabits. So this is 24 gauge solid strand wire, which is what we use in network. 5E, 5E, 5, 5E, and 6 we use for local area networkings, and they have a 7, but that's usually used by commercial telecommunications.
That's for line loss or packet loss, crosstalk.
Well, yeah, but what we're doing is what we use what we call twisted pair cable. And what the twisted pair cable does is, so the twist, the number you have, twist you have, and of course how close they are, sets the characteristic impedance of the wire, of the cable. Now this is what we use. We use 4 pair. The color code is standard, and it goes with a solid wire, and it's wrapped with a striped wire. So orange, white, orange, orange, white, orange striped with a white, solid orange, green, white, green, blue, white, blue, and brown, white, brown. So these are the standard colors that we use in network. The biggest mistake people make with this one is unwrapping these twists to make it convenient. I've seen networking guys come in and they'll strip them off. Yeah, and what we got to do is we got to maintain this twist as best we possibly can through our splices and through our terminations, even though it's a little inconvenient for us. First thing we're going to look at is a punch down block. And James is going to have to find our 66.
Over here.
I don't know. I haven't seen it. I looked over it.
I know I was working on that.
We call this a 110, and exactly why it's got that name, I think it's something to do with the spacing between it. I don't know. So many spaces for over distance. We have 2 methods that we can wire these things. No, these are 110s. I can't find the big 66 punch down. So the 66 punch down. So the 66 punch down block looks like these, James. So they're. No, it's not going to be in a drawer. It's a block. It's a block. It's a big thing. You're not listening to me. That's a 110.
Okay.
And we're supposed to have a couple of them over here, but these are the 66 punch downs right here. This is the ones we got, and they got a blue.
Okay, I know one.
They got a blue cover on them. Somebody's lost the cover off this one. This is a punch down tool. Yeah, it's a punch down tool. They usually come with two sides. If I can get it out. So this is the 110. They usually come with a 110 punch down tool, and then they come with a 66 punch down tool. So this is the 110. Sorry, this is the 66. So that's one of the big 66s on there. And then if we pop this one out, we see this is the 110. So the 110. Most of them they ratchet in.
When you look around, is it like one that you've got two different kinds in there, or is it just?
No, what we do is we go to, if we're going to use the 110, what we do is we take this one out and then we put the 110 block. I haven't
Okay,
seen
so
one.
it's only one side.
All right, for this tool, I'm not saying you can't get a double sided. I just
No,
said
I'm
that-
just that's unique. No, it doesn't.
it's not. And what we have is we have blade on one side, and we'll see that 66 is a little different. I mean, 66, it's got a longer blade, and it's got a flat side. And the 110 is going to cut it just a little bit different. You can grab this and actually strip the cable. This is, what we're doing, of course, I don't know if I showed y'all cut off those. That is now. Internal.
We got a whole school of campfire.
Yeah, we have. So there's a spool over the hydraulic, over the hydraulics too.
What about running this in conduit?
Without running it.
I mean, it don't matter. None of that matters.
You can run it in conduit.
Okay. I have.
Usually you'll run it in conduit, like you have to come down through a wall like this. These cables are rated different. The jackets are rated different. So like I said, this is a CMX. We can look at that communication X. We'll look and see what kind of cable that is. Now this is 24 gauge Cat 5E. So this CMX, that would be the jacket, what the cable's rated. What we do is this is a stripper. We have different methods we can do that. And what you have the ability to do here is it's got a set screw on it where you can adjust the depth. And so what we have is we got this where we set, so we should be able to strip this. You just spin it, and then you come off, and then you can pull the jacket off. And if you do it right, you should always check. And I bend it on purpose because if I scribe the insulation, it would break, and I would be able to see the copper wire, and I know that I screwed it. And then, of course, the strength member, it didn't even cut the strength. So this is a 66 punch down. So this is what you'll see. 110 punch down. This is usually mounted in the boxes that you pull it into a wall. Notice it's got snaps on it, so it snaps in. So all you see is this part right here. Here's the actual punch down. We have two methods we can hook this up. We can do what they call a 568A or a 568B. What you got to understand is that there's really no set standard, but you got to do both. So if you want to do what they call a crossover cable, then what you would do is you'd wire a crossover cable. The problem we have is that the network cables are set up, so we're going to hook these into something. So I have the ability to take a cable out of here and plug it directly into another computer. Well, the problem is that both of them is going to be trying to transmit on the same wires. So what you would do if you want to create what we call a crossover cable, then what you would do is you would wire one cable for what we call a 586A, and then you'd wire the other one for a 586B. And that creates a crossover cable, which gives you the ability to connect two computers together without going through a switch or a router or anything like that. Standard is that if you're just making a cable, you wire both of them 586B. And what you do is, it's kind of strange. Literally, you could come up with your own scheme. But the problem is now anybody that comes in there after you have no idea what you did. And the other problem you have is the way it transmits is that you might be using two wires that are not twisted together. So you might be using one wire for your transmit plus, and then the other, you might be using another wire over here for your transmit receive, and they're not twisted together. And if they're not twisted together, then you've lost the capabilities or the electromagnetic interference of a differential signaling, which we went over on the video. So we use differential signaling, but differential signaling requires, for it to work, it requires the two pairs to be in twist. So if you make up your own color coding, it's kind of strange the way they decided to do that. So what we're using is we're using an 8-pin connector. We're using 4 twisted pairs. And if you look on this, this tells you how to wire, and what's nice on all these is it tells you the color code. So the top color code would be if you're hooking up a B connector, and then you see it's on both sides. So B, and this right here would be B. Okay, understand? Yes or no?
Yeah.
Or A. So notice what they do between the A is they roll the green and the green white and the orange white. So the green white, so one of them's transmit, one of them's receive, and that's what you're doing between a 5 and a B is you're rolling the green. That's a
5 and a B.
Yeah, between an A and a B as they roll. So B, the color code is orange. It's orange, white, orange, green, white, green, green, white, blue, blue, white, green, brown, white, brown. And this would be for the B. For the A, it would be green, white. It would be green, white, green. Then it would be orange, white, blue, blue, white, orange, brown, white, brown. So you see all they did was roll the green and the orange. That's all they do between A and B. So we're using 8 conductors, but on Ethernet we only use 2 pair of, which leaves the other 2 pair ready for other things that we could use in the cable. So I could literally use this cable to run multiple things. Like on ours, we're using voice over IP. So what they're using is they're using one of the pairs to power up the phone. So that's the voice in our offices. So here's the 2 pairs right here that actually are your transmit and receive. And then these 2 wires here are used on some extremely high speed networks, which gives you the ability to produce. So what we do on the punch down is, what we want to do is we want to come in here and we want the insulation on the jacket to fit right in this groove right here before the first punch down. We don't want it strung all the way out here, which you see a lot of people do. And we want to maintain our twist all the way up as far as we possibly can to the punch down. So what I would do is I would just come over here and lay this down, and here's orange, white, orange, and I would just come up here and I would just untwist this because we're going to cut it off anyway. And then I'm going to come over here and I'm going to lay the orange, I'm going to do the B, I'm going to lay the orange into the groove right there. And then what you do is you take your punch down. This is the blade, this goes to the outside, so the blade goes toward the loose wire. And then what we would do is we would take this. So we do this and keep it okay.
You can hold the cable.
We're gonna lay it into the groove. You see, I laid it into the groove, and then I take the punch down, and I put it in there, and I push it down, and it automatically inserts it in there.
Yeah, and cuts it.
Yeah, and what it is the blades in there actually literally cut into the insulation and into the wire.
Open
So you don't have to remove any insulation. People think you need to do that. So what we do is we take it. So here's our, now notice I'm keeping my twist all the way up. I push it down in there a little bit so it don't move. I take my punch down, blade toward the loose end.
Listen,
You should know.
wait for the listen.
Yeah. You see some people do it multiple times. And then now we're through. And then so notice it automatically strips it off. And when it pushes it down in the blade, it cuts into the insulation and makes contact with the wire. Are we okay?
Some of the RJ45.
And I've seen guys, they'll come up here and they'll strip it way back and they'll untwist it all the way out and lay it in there, and it'd be well, what you got to understand, if you change the impedance of the cable, what happens is Ethernet is downwardly compatible. So we've gone from 3 megabits to 10 to 100. Now we're in gigabit. But the problem is, when it tries to make that connection, if it can't make it, it automatically drops down to a lower speed. So just because your network's working does not mean it's right. It might not be working at the speed that it was designed to work at. Because that's what it's going to try to do. It's going to try to make a connection. This is a technique they brought back from old cable modems, phone modems, where they had so many standards out there that if that modem just supported that one standard, then you couldn't connect to everybody. So what the modem would do, it would set up what they call a handshake, where they'd start sending stuff back, and then they establish the speed that they can communicate with the least amount of errors. So this is a 110 punch down. It's basically the 66 is the same method. It's just that the blade's a little different. Oh, it's already out. And I don't know who lost the cover on this. You need to keep this cover because this guy right here is pretty sharp. But this is the blade for the 66. So what you do here is that this is hollow in the center. And, the blades in the 66 run like this. You should draw them different. And what happens is your punch down tool actually fits over the blades. And then when you push it down and it snaps, it cuts the wire. It'll be extending out like this. So this one, the 110, the way the 110 punch down block is set, see, it's got these grooves. So this thing here, you can see this is laid right here. See that? So it literally slides right down that groove right there. The 110, the 66, notice that it's hollow. See what I'm talking about? So when you set it down, it literally slides over the connector on the punch down block. We use a lot of 110s in wired networks, so they come in with some type of premise cable or a cable that's got a bunch of wires. So if I'm bringing in a network from the outside or from another building, and I'm trying to bring it into my building, I'm not going to run individual cables like this. You ever looked at a telephone cable? It's huge. So what they'll do is they'll come down and they'll come in with a cable, and then they'll come into a 66 punch down. And then they take the individual phones and bring it into, or individual lines and brings it into that punch down. So they bring a cable into the punch down, and then they come out with individual wires. That makes sense? Mm-hmm. So we probably got them around here somewhere where we have what they call
Basically, distributor.
it's a distributor, right? Coming in with a big cable, and then coming out with individual cables like this. Huh? I wouldn't take a break. Should I take a break? I don't know. show you how to do the what we're going to do is we're going to put a connector on there. It's the RJ45 connector. And this is an 8, of course it's for Ethernet, wired Ethernet. This is the tool that we use to put the connector on and everything else. It's got a wire stripper in it. It's got a jacket stripper on it that's set right. Go up there and cut the jacket off the then what we do is we're going to come up here and we're going to deliberately fan this out. Coming out of the twist. Let me cut off my string. We're going to come up here and untwist it. Because when you do it right, we're going to maintain the twist. Then what we have to do is we need to, and how much you strip off, you just need to make sure you need enough slack for, some people really strip this off. We'll unstrip them and twist them. Try to do that. Yeah, we'll do the B. I think it's what we asked. Maybe I'll do a B and A. Then what we do is we can just take this and we just rip. What we're trying to do is get a twist out of the table as much as we can.
You start getting close, it's hard to handle. You start getting close to that end, trying to hold them apart to get that stuff.
Then what we do is we come up here and we put them in the order that we want to do. So if we're doing the B, we're going to do orange, white, orange. Try to get them in that order. Orange, white, orange. Blue, white, green. And that's why if you just make it up, odds are they're not going to be twist. Green, right, blue, brown, white.
Wait a minute. Okay.
So that's,
Orange.
we're doing the 560, and we got a thing over there.
That one on my wall.
So using the 586. Okay, so here it is. Orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. And once you, there's no telling how long. Then what we're going to do is what we're trying to do, we're trying to get this when we insert this into it. We've got to get, so here's the crimp. Oops, let me get the camera back up. So here's the crimp for the jacket right here. So that means we've got to get the jacket to come in right here. Because if you get it back here, you don't have a crimp on the jacket, and that's what we want to do. We want to crimp the jacket. And then what happens is this guy's got blades in it. Right now you can see all the pins are sticking out. And when we crimp it, what it does is literally take those blades and punches through the insulation, and actually makes the connection with the wire. The biggest thing to do, the biggest thing you're doing is trying to maintain this color code when it goes into that dang thing. They don't want to twist around with it. So you make sure you double check this before you crimp it. So what we mean is we're going to come up here. So I'm going to look at this, and after a while, once you do it a long time, you'll see I need it to come out to right about there. So what I'm going to do is that's what this guy is right here. This allows us to come up here and put these together, and then we can come up here and we can cut them all at the same time. And then we end up flush. Then what we do is we hold them in our hand, double check, orange, white, orange, blue, white, green. See, I got one to twist. Okay, orange, white, orange, blue, white, green, green, white, blue, brown, white. And what we do, looking at the pin side, that's your color code, is looking at it from the pin side. Then we're going to come in here and we're going to slide these in. And we're going to push it all the way down. And what we're looking for, we're going to turn this over, and I need to see all the little old copper dots right here. You can see? And so what I'm looking at the end of each one of the conductors. If you can't see one of those little copper dots up there, it means you need to try to push them in further. Huh?
I did that the other day while y'all was here. Y'all probably didn't see
See,
that.
that's different from the way I do it. I'm just saying, orange, white, orange, green, white, blue, blue, white, green,
Brown, white, green.
brown, white, brown. That was
Orange, white, orange.
green, white,
Blue, white, green.
That should be green, white, blue. Green, white, blue, blue, white, green, brown, white, brown.
Orange, white, orange. I did put green, white. Yeah, the green, white is very, very critical. Because if it's not, that's one of your twists.
Well, learn how to make crossover there.
Oh, it is. Flip or flip on you?
Yeah.
Oh, man.
Orange, white, orange. Orange, white, orange. Orange, white, orange. Green, white, blue. I think it's trying to get into. White, orange. Orange, white, orange.
It's going to be more difficult because you already cut.
Yeah, I'll make it short. We can always go back and redo it. We leave around orange, white, orange. Green, white, blue. Yeah, it is.
Alright, I have it set at 0.1 meters per second.
Well, you gotta be,
Which is 100 millimeters per second, 100 millimeters per second. That's how fast it's moving right now. Capable of moving 800 millimeters per second. Like, it's already moving pretty fast.
well, you mean you have it set, you have it set in your,
Like the
the
velocity
program?
for the point to the point movements is about 100% velocity.
No. That robot is in meters.
Meters, yes, exactly. So I have to transfer.
Well, what, that means if you're 100 millimeters per second, you're gonna put 0.1.
That's what it's at right now. But I was saying the maximum velocity for that thing is 0.8.
Okay.
So it's only moving at an eighth of the speed right now that it can fully function at.
100 millimeters per second is not very fast. You don't have one, you got
Yes, it's at 0.1. It's still, I mean, I'm looking at it. It's moving pretty fast.
okay.
I mean, in the confines of space within,
Yeah, that thing is,
It'll jerk around.
it's good.
not sure how old he is.
So,
I'm not sure how old he is.
Sounds like he's very fascinated.
most people are.
They tend to not get too fascinated when they realize it's taking their whole job and they
We put electronic scales into the city of Birmingham so they could get a more reliable method of people pay and how much work your trucks did. And they had a guy that worked over at Eastern landfill. He could tell you how many yards of garbage. If you pulled up with a truck, he could look in there and tell you about how many yards of garbage you had. And we put that digital scale in there. He hated that thing real fast.
Because it took his job.
No, it didn't take his job. It made him learn.
It made him learn.
They had to learn how to use that computer.
Then I could just,
So what they would do is they would pull up on the scale, and then they were doing a gross and a tear. You'd weigh them coming in, and you weigh them coming out. That's how much you know what kind of
Yeah.
garbage they got. Well, so what they do is they'd come up to the window, they'd weigh their truck, they'd give them a tag, they'd go out there and dump their truck, and they'd enter that into the computer, and they would tell them what tag number to print out, and give that, and they'd come back, and they'd pull up on there, and they'd give them the tag. The guy had to punch that number in the computer, and it would give them that gross. How much?
he found a shortcut.
Oh
I
man,
can
no,
already tell.
but he couldn't do it. He had to start
Right.
doing it. That's the way it was.
Yeah.
So he had to learn how to use that computer. He had never used a computer in his life.
Yeah, I wonder what the
It
yield was.
Go there and get another. Oh, I encrypted shit.
No. I wonder what the yield was on there. Like the difference between the two.
I don't know. I remember this. I just remember how many problems he had going from doing it the old way. So yeah, they had old sticks that take out there. Orange, white, orange.
Green one.
Green, white,
Blue,
white,
white,
green.
blue. Blue, white,
Of where it meant
green. Brown, white. And then we want to make sure we do what? Of course, I've done it so long, so many times I can do it. I know about what my finger needs to do. So we want this jacket come up past the groove. We'd like it to come in and hit right there, right?
Mm-hmm.
And that means I need to cut it. Cut that in. Orange, white, orange. Green, white, brown, white.
So pretty.
Yeah, it is,
It's hard to
because
hold together.
if you do it the same way on both sides, it'll electrically be right work, but you'll have your twist, your pairs messed up.
Do it electrically on both sides. So you need an A and a B side.
Well, only if you're doing what we call a crossover cable. If you're doing a crossover cable, then you do an A on one side and a B on the other side. Orange, white, orange. Okay. Like I said, a lot of times you can push it in a little closer, but what we're looking at is we want to flip it at and look at it straight on the end and make sure we see what? All those little copper little dots up there indicating it's all the way up. By the way, you can get these that does the RJ11s, which are the ones they use in the telephone system, and that. I like this one because it's got the jacket stripper on there that's already set for you. Well, that's not true. You can adjust it, and then it's got the cutter that you can cut all of them flush with each other,
All in one tool.
all in one tool.
I have the cheesier one from Lowe's, which got both connected on it. And my jacket stripper cuts my wire every time.
Brown, it was a little bit short when I moved in.
That's okay. What you do is, of course, you got a lot of play, and we want to make sure our jacket comes past the crimp for the jacket, right? You understand that? And then insert it into that. And you need to make sure these are the fingers right here that actually pushes the pins down into the wire. So insert it in, and come up here and grip it, and push it down. And then it pushes the pins down for us, and it actually does what?
Connection.
Cuts into the insulation. Now our jacket's in there. So that's a determination. Now, some people use them, some people don't. We're going to use the boot. Now, what's nice about the boot is that it protects this old plastic tab up there. See, if you've ever had a phone, sooner or later you're going to break those little plastic tabs off your phone. And then once you break that little plastic tab, that's the latch for the cable. So what we normally do, the better cables are going to be made with the boot. What you got to remember to do is what?
Put the boot on
Put the
first.
boot on there first. And then the boot slides up on it, and what it does, it protects this little piece of plastic right there. That's the main thing. I don't know how many I've seen that's got broke off, and once they get broke off, yeah, I carried one over to what we might let y'all do. We got a computer lab over in the hall building, and it's got a bunch of computers in there, but only some of them are wired up to the network. So what we'll probably do is I'll go over there and figure out what links we need. So instead of going by the actual lab, what we'll probably do is we'll just let y'all make the long cables. I think we'll do B's on both sides. I guess that's it, guys. So we did another thing that we're going to do is we're going to do a Molex connector. Like I said, this is a Molex connector. Now they could have a gender. Normally the gender of the plug is depending on what we use. So this would be the female, and then this. Well, I got two females, and then the male would insert in this. So if you got a plug that's got all pins in it, then that would be the male connector. And if you got the one that's got the tubes that the pins plug into, we call that a female connector. And, it's not sexist, that's the way it is. That's the terminology of trade. But what we do on this is if we look at the connector real close, I don't know if I can show it here, it showed up real good on the video, is that we have two crimps that we have. We have one for the insulation, which is on the back, and then we have one on the wire, which is for the conductor, which is below that. So what we do is we'll take whatever we're going to use, and somebody go get me the stripper. That's good. So what we're going to do is I'm going to show you a little dry fit. So what I'm going to do is I'm laying the wire down there. And so I'm going to come up right here. And this is how much I want to strip off of it. So I want the insulator to be crimped in the back. And I want the wire to be crimped in the front. And what I'm going to have to do, I'm going to lay it in there. And I'm going to strip it right there. So I get my wire stripper. Get the right gauge wire. And then strip it off. And then we'll dry fit it. And so that's about perfect. Now this is the crimp tool for the Molex. I think this says conductor, but I think the ones we got is so small we'll have to use this on both sides. You can see, if you look real close, you can see it's got this little indent right here. What's going to happen when I crimp this thing? And these pins, these are a lot smaller than what these. We'll lay it in there like this. Here. Let's see where I got it in there. And you crimp it. What happened, if you notice, it's probably better for me to show you. I'll show the way it is. I don't think it's going to show up on the camera. If you see the way it bended in, it bent those two ends into the insulator. You see it? So the pins we had was a lot bigger. So even though this says conductor, I think I used the 2.3 on that side. And then we'll probably use the 1.8. That, and then what we do is we'll choose the right size for the other the conductor. We want to lay the wings so they're up. And then when we crimp it, what happens is we come up here and roll them around. Crimp them.
Okay.
Then it's got these two edges on these wings that stick out. And what we do is we insert it where we want it to in the thing. And when you push it in far enough, the wings are going to latch it in. See now, I'll come out. We have to have a special tool to get this out. And I don't think I brought it over. So a special tool, I think it was on the video, it's got a hole, you stick it down there and it pushes those wings in and allows you to push them out. Of course, if you come up here and put enough stretch, you're going to either pull it out of the socket or you're going to bend those wings out, right? I understand that. So that's all of them. So these are the ones you're going to do. If I can find my 66, we'll do a 66 punch down if I can find it. If not, we'll just do the 110. We're going to terminate a
RJ45.
We're going to terminate an RJ45 connector. We're going to put on a receptacle, electrical receptacle. Where's that at? We're going to do a splice with a wire nut. We're going to put on an electrical receptacle on the same wire, so yours will end up looking like this. You'll have the splice in the center and then the receptacle on the other side. And those are the labs that we're going to start working on. Once y'all finish the lab, they're on that. Then we'll have a test. We'll be in lab the first of Thursday, right? We'll start off in lab on Thursday, and then we'll take our test at the end of the class, and then y'all be off for a week. 5:30.